Hello everyone. In this video, I'll be showing you guys error calculation in physics. Okay, so in this video, we are going to look at absolute error, relative error, percentage error, and standard error. Okay, now we start with the absolute error. Absolute error actually is the difference between an experimental value and true value. Okay, so you can have that formula that absolute error is equal to observed value minus true value. Okay, now the absolute value of a, we write it as dA. So when we say error of a is dA, actually that's the absolute error. Now the relative error is absolute error divided by the original value, that means dA over a. Okay, that means the error in a all over a is the relative error. And finally we have that the percentage error is the relative error multiplied by 100. So this is it. So the relative error multiplied by 100%. Sorry, that's a mistake. That is dA over A multiplied by 100. Okay. So that is it for percentage error. At the end of the video, we'll be looking at standard error. So let's continue. Now look at this. The first we're going to look at is the error in sum or difference. So you have there that if y is equal to a plus or minus b, then dy must be equal to dA plus dB. What that means is that whether I'm adding two values or I'm subtracting two values, to find their errors, I must add their errors. Let me give a very quick example. Let's say I have a to be equal to 2 plus or minus 0.1 as the error. And I have another value b to be equal to 3 plus or minus 0.2 here is the error. And I'm asked to find the error in a minus b. Now this is what is going to be. Now a minus b, first of all, I'm asked to find a minus b. A minus b actually is 2 minus 3. And 2 minus 3 is equal to minus 1. Okay, but I'm asked to, I'm also supposed to calculate their error. Their error is going to be dA plus dB. That means error in A plus error in B. Whether I am adding or subtracting, I must add up the error. So the error in A is 0.1. Okay. And the error plus the error in B is 0.2. Okay, so that will give us a total of 0.3. So, okay, so that's what we have. So it means that my A minus B, I can write it as A minus B now is equal to a minus b gave me minus 1, then plus and minus my error is 0.3. So that is how to make that calculation. Error is 0.3. Okay, so let's move on. We see a question here. It says given that p is equal to, given p equal to 1.2 plus or minus 0.1 centimeter. Then Q is 2.0 plus or minus 0.2 centimeter. And R is 105 plus or minus 5 centimeters. So we are asked to calculate the absolute error in P plus Q minus R. Just the absolute error. So we're interested in just the error. Now, let's Y be equal to P plus Q minus R. Since we're interested in just the error, that means my error in Y will be equal to error in P plus error in Q plus error in R, because it has to do with addition and subtraction. Okay, so that means my error in P, which is 0.1, so I'm going to have 0.1, then plus my error in Q, which is 0.2. Okay, then plus my error in R, which is 5. Okay, so that will give us a total of 5.3. Okay, so 5.3 as our answer. So we've answered the I question. Now the next is the relative error in P plus Q plus R. Now let's see that. If we are to find the relative error in P plus Q plus R, I will need to add, I can say let Y be equal to P plus Q plus R. Okay, first of all, my P is 1.2 plus my Q is 2.0, then my R is 105, which if we add, we are going to get 100 and, okay, I think 108.2. Let me do that quickly. 1.2 plus 2.0 plus 105. Okay, that is giving us 108.2. So we have 108.2. Okay, so that is the y, but that's not what we're interested in. We're interested in the error. So what is the error? We've calculated the error. The error in y is equal to the error in P plus the error in Q plus the error in R, okay, which is equal to, we've done that earlier, 0.1 plus 0.2 plus plus 5. So that gave us 5.3. 5.3. Okay, so at that point we can now find the relative error, because the relative error is the absolute error all over the original value. The absolute error is 5.3. The relative error is 108.2. Okay, so what would that be? So let's do that quickly. So here, to find the relative error, rub it off quickly. Okay, right, so my relative error is error in y all over y. Okay, so that's the formula for relative error. The error in y, we had it to be 5.3 divided by y itself is 108.2, and when we do that, we are going to get 0.049. So the answer here is 0.049 as the answer. Okay, that's quite beautiful. Now we make progress. We move to the next. Here is error in multiplication or division. Okay, the error in, if y equal to ab or a over b, that means multiplication, ab is multiplication, a over b is division. Then dy over y is equal to dA over a plus dB over b. What that means is that the relative error of y will be equal to the relative error of a plus the relative error of b. That means if I am multiplying two values or I'm dividing two values, I can use relative error to find the absolute error according to that formula. Now we see another example. Let's see an example. Here it says given that P equal to 1.2 plus or minus, the same question we solved earlier. I says we should find the percentage error in P times Q times R. So for us to find percentage error, remember our formula for percentage error. Percentage error is the relative error. That means the y over y multiplied by what? By 100. Okay, so we are going to achieve that now. First of all, we are going to say let y be P times Q times R. P times Q times R. So my P is 1.2, like we know, times my Q is 2.0, then times my R is 105. Okay, so if we multiply that 1.2 times 2.0, then times 105, that will give us 252. So my error here is 252. So please, we can write that down. So your y, sorry, is 252. Now we'll have to calculate the error in y. Now because P, Q, and R are multiplying each other, then my error in y is going to be, I'm going to add up their relative errors. That means the y over y is equal to dp over p plus dq over q plus dr over r. Okay, now dp over p here is 1.2, oh sorry, dp is 0.1, that's the error in p. All over p is 1.2. Okay, 1.2, sorry. Then plus dq over q, your q is dq, error in q is 0.2. Now all over q itself is 2.0. Okay, then plus dr over r, error in r is 5. Then r itself is 105. Okay, so let me calculate that quickly. So we have 0.1 divided by, okay, we have 0.1 divided by 1.2, then plus 0.2 divided by 2.0, then we have plus 5 divided by 105. Okay, we are going to get 0.23. So that means the error here, percentage error here is 0.23. That's the relative error. Okay, but I can see that in the question we are asked to find percentage error. So that means we don't need to, we wouldn't have done the p times q times r, because percentage error is simply relative error multiplied by 100. Which means my relative error here is 0.23 multiplied by 100. So the answer is simply 23%. Okay, so that is it for the percentage error. Now let's see the next question. The next question says we should find the absolute error in PQ over R. Now to find the absolute error in PQ over R, okay, let me clean this up. Okay, so in PQ over R, we can start by saying let y, here we will need to find y actually. Let y be PQ over R. Your P is 1.2, your Q is 2.0, then divided by 2.0, sorry, then divided by R, your R is 105. Okay, so if we multiply that, if we perform that, we have 1.2 times 2.0 divided by 105. We are having 0.023. So this is giving us 0.023. Okay, so that's my value for y. Now the next thing is to find the the error. Now how do we calculate the error? Please store the value 0.023. Now for the error, since PQ over R involves multiplication and division, we can just say error in y over y is equal to error in P over P plus error in Q over Q plus error in R over R, which we have calculated to give us 0.23. Okay, we get 0.23. But in this case now we are asked to find relative error. So I'm going to have dy over y. My y, we calculated y to be 0.023. 0.023. Okay, all is equal to 0.23, which is what we calculated as the relative error. So, but I'm looking for the absolute error, which is dy. So in that case now, my dy now will be equal to 0.23. My absolute error 0.23 divided by 0.023. Okay, so you have 0.23 multiplied by 0.023. We are going to get 5.29 times 10 to the power minus 3. So that is 5.29 times 10 raised to the power minus 3 as the absolute error. Okay, So once you get your relative error, you can find your absolute error by imputing the value of y and you're okay. Now let's move on. So here we have error in exponents. This, if y is equal to a raised to power n, then the y over y will be equal to n. You multiply by the power n times the relative error of a, the a over a. Now that is very important. So it means that if, let's say, I have y to be equal to a raised to power 3 and I want to find the error in y, it means that the error in y will be equal to 3 times the error in a, or the error in y over y, sorry, will be 3 times the error in a over a. And that's exactly what that should be. If, for example, I have a formula, let's say y is equal to 2.0 plus or minus 0.1, and I'm asked to find the error in y raised to power 3. Okay, I can start by saying let p be equal to y raised to power 3. That means the relative error in p will be equal to 3 times the relative error in y. Okay, and which means that my relative error in p, the p over p, will be equal to the 3 times the error in y is 0.1. Okay, 0.1 all over y itself is 2.0. So with this now you can see that we can find 3 times 0.1 divided by 2, that will give us 0.15. So the whole of this now is equal to 0.15. That means the error, the relative error in p. Then if I'm asked to find the absolute error in p, then I can impute the value of p, which is y cubed, and cross multiply to find that. Okay, now this leads us to error in trig ratios. If y equal to sine x, you should know that the y, that's the error in y, will be cos x dx. Please note that. If y equal to cos x, then the error in y, dy is equal to minus sine x dx. If y equal to tan x, then dy, which is the error in y, is sec squared x dx. And also if y is equal to exponential x, then dy is equal to exponential x dx, which you can also write as y dx since exponential x is y. Okay, you can write this as y dx since exponential x is y. So please let's note that. Okay, so that leads us to a question. Look at this. It says given the mass and volume of a sphere as m equal to 30.2 plus or minus 0.1 grams, and r, sorry, not volume, radius, please correct that should be radius, and r equal to 2.7 plus or minus 0.05 centimeter cube, determine its I volume, then I density. Okay, now let's start with the volume. We know that the volume of a sphere is supposed to be V equal to 4 over 3 pi r cube. Okay, which when we substitute value, we are going to get 4 over 3 times pi is 3.142. Then times r is 2.7 from the question. 2.7 raised to power 3. So if I use my calculator, I get 4 times 3.142 times 2.7 raised to power 3 and divided by 3. Okay, so that's giving us 82.46. So the whole of this is equal to 82.46. Okay, so 82.46. That is for V. But you can't find volume without finding the error in V. So let's find the error in V. Now, based on the formula, we say that V is equal to 4 over 3 pi r cube The variables here are just v and r cube. We are not concerned with the constant. So if I want to find the error in v, I would say dv over v is equal to, forget about this, r is cube. That means it will be 3 times dr over r. That's the rule. That's how it works. Okay. And in that case now, this will be equal to 3 times dr. Our dr is 0.05. Our dr is 0.05, then divided by 2.7, which is r. So if we calculate that, we are going to have 3 times 0.05 divided by 2.7. That's going to give us 0.056. So everything here is 0.056. Okay, so if we continue with that, permit me to rub this off. If we continue with that, we'll see that dv over v being equal to 0.056. Now, but our v is we got our v earlier to be 82.46. So I can clean v here and replace it with 82.46. So that means my error in v is to cross multiply 82.46 multiplied by 0.056. Okay, so we are going to get 0.46 multiplied by 0.056. Yes, we have 4.62. We have 4.62. Okay, so that means this is to say that our volume, the final answer of our volume, finally, is that V is equal to 82.46 and plus or minus 4.62. Okay, that's the answer for V. Now we go ahead to find, the next question says we should find the density. Okay, let's rub this off as we find density. What is the formula for density? Density is simply mass all over volume. Density is equal to mass over volume. Okay, so the mass here is 30.2. Then divided by the volume here is, we got volume to be 82.46. Okay, so if we calculate that, 30.2 divided by 82.46, we are going to get 0.366. So this is 0.366. Okay, but we need to also find the error to write it clearly. So what is my error? To find the error, since this is division, we can say that the error in density over density, that means the relative error of density, is equal to the relative error of the mass plus the relative error of the volume. Relative error of mass is 0.1 all over 30.2 over 30.2. The relative error of the volume is 0. The volume, we got the error earlier. Let me get the error is 4.61. So I should rub this off. Sorry. So the error of the volume is 4.61. 61 all over the error in density. The error, all over the volume itself, which is 82.46. 82.46. Okay, so if I use my calculator, I have 0.1 divided by 0.1 divided by 30.2, then plus 4.61. 4.61 divided by 82.46. 82.46. Okay, so you're going to get 0.059. So that means the relative error of density is 0.059. Okay, so we'll have 0.059. Okay, good. Now, but we should find the error in density. So let me clean this up. So when we say the relative error, the rho over rho, the relative error of density is equal to 0.059. Okay, but that means the relative error, we can replace the density here with the former value we got for density. We said that density is 0.366. So we have 0.366. So that means the error now will be equal to 0.059 multiplied by 0.366. Okay, so that will give us that gives us 0.021. 0.021. Okay, so that means my density now, I can state that the value for my density now is equal to 0.366, sorry, plus or minus 0.021. 0.021. Okay, so that is it for this very video. Watch out for the part 2 of the video. Thank you.